In this video, we will solve question paper of exam. So, first question was, find the roots of the polynomial x square minus x minus 1 through fixed point iteration method. Also make a table for various possible equations and show their nature, whether they are convergent or divergent in nature. So, to solve this question, we have to make some assumptions which are, let fx is equal to x square minus x minus 1, where f at 1 is negative and f at 2 is positive. So the root is between point x is equals to 1 and x is equals to 2. So we can take x0 as 1.5 as median value. So let the function x square minus x minus 1. So we can take equation gx that can be made through fx. The possible equation gx that can be made through fx is given in this table, where gx is equal to under root x plus 1, g dash x is equal to 1 upon 2 root x plus 1, where g dash 1 is less than 1 and g dash 2 is less than 2. For the selection of correct gx, so g dash x should be less than 1, and if the multiple value of gx are less than 1, then choose the least one. So table of convergence is root 1 x plus 1. So g dash x is equal to 1 upon 2 root x plus 1, where g dash 1 is less than 1 and g dash 2 is less than 1. Therefore, it is convergent. For the second equation, 1 upon x minus 1, where g dash x is equal to minus 1 x minus 1 whole square, which is greater than 1. So g dash 2 is greater than equals to 1. Therefore, the equation is divergent. 1 upon x plus 1, where g dash x is equals to minus 1 upon x square. So g dash 1 is greater than equals to 1 and g dash 2 is less than 1. Therefore, the equation is divergent. Fourth equation is x square minus 1, where g dash x is equals to 2x and g dash 1 is greater than 1 and g dash 2 is greater than equals to 1. Therefore, the given equation is divergent. The gx is equals to root x plus 1 should be taken for a fixed point iteration method. X0 is equals to 1.5, x1 is equals to root 1.5 plus 1, x2 is equals to root 2.5, which is equals to 1.511, x3 is equals to root 1.5811 plus 1, which is equals to root 2.5811, which is equals to 1.6065. X4 is equals to root 1.6065 plus 1, which is equals to root 2.6065, which is equals to 1.6144. X5 is equals to root 1.6144 plus 1 is equals to root 2.6144, which is equals to 1.6169. X is equals to 1.6169 plus 1 is equals to root 2.6169, which is equals to 1.6176. So we will take this till x hat, which is equals to root 1.6179 plus 1, which is equals to root 2.6179, which is equals to 1.618001. As the error between x7 and x8 is 0.000101, and the root of x square minus x minus 1 is 1.618001. So let's now see question number 2. Find the solution of a system of the equation using iterative method. So the given equations are 20a plus b minus 2c is equal to 17, 3a plus 20b minus c is equal to minus 18, 2a minus 3b plus 20c is equal to 17. Now we will find the value of a, b, c in the respective equation by taking variables from one side. So the given equation is a is equal to 17 minus b plus 2c by 20, b is equal to minus 18 minus 3a plus c by 20, c is equal to 17 minus 2a plus 3b upon 2a. So let a0 is equal to 0, b0 is equal to 0 and c0 is equal to 0. So a is equal to 17 minus 0 plus 0 by 20, b is equal to minus 18 minus 0 plus 0 by 20, c is equal to 17 minus 0 plus 0 by 20. So a1 is equal to 0.85, b1 is equal to 0.9, C1 is equals to 0.85. So A is equals to 17 minus 0.9 plus 2 into 0.85 by 20. B is equals to 18 minus 3 into 0.98 plus 0.63 divided by 20. C is equals to 17 minus 2 into 0.98 plus 3 into 0.905 by 20. So A2 is equals to 0.98, B2 is equals to 0.985, C2 is equals to 0.63. So now A is equals to 17 minus 0.985 plus 2 into 0.63 by 20. B is equals to minus 18 minus 3 into 0.98 plus 63 by 20. C is equals to 17 minus 2.98 plus 3 into 0.985 by 20. So A3 is equals to 0.96225. B3 is equals to minus 1.0155. C3 is equals to 0.6042. So now A4 is equals to 961195, B4 is equals to minus 100141, C4 is equals to 0.6014. So now we will follow this steps till the repeated approximated value is there. Now let's see question. Next question. List out 4 disadvantages of Gauss elimination and 3 advantages of iterative method over elimination. So the iterative method is superior to the elimination method due to computational error is approximated 2 exponent to arithmetic operation per iteration, and if the conversion is achieved in less than an iterative, it is significantly superior compared to the elimination method. Another important advantage of the iterative method is small rounding error. The rounding error being one committed in the last iteration. Thus, for all condition system, an iterative method is good choice. In Gauss-Seidel method, we set xi equals to the newly calculated value of the iterated code in temp. The disadvantage of Gauss elimination are as follows. The computational effort is approximately 2n3 by 3 arithmetic operations in each elimination step. The amount of the bookkeeping necessary is considerable. The rounding error may become quite large, particularly for ill-conditional equation. Any special structure in the matrix or the coefficient is difficult to preserve during elimination. The next question is, write the algorithm for the Lagrange's inverse interpolation. So first we have to read the number of inputs n, read the value of x. For I is equals to 0 to I is equals to n minus 1, read x comma y. Set sum is equals to 0. For I is equals to 0, I is equals to n minus 1. Set product is equals to 1. For j is equals to 0, j is equals to n minus 1. If I is equals to j, then the product is equals to product star y minus yi upon yi minus yj. So sum is equals to sum plus xi into product. Print sum. So this is the algorithm for Lagrange's inverse interpolation. Now the next question is evaluate 1 upon 1 plus x square for the limit 0 to 1 for the 3-point Gauss quadrature formula for the given abacus and weights. So T1 is equals to 0.77459667 and T2 is equals to T3 is equals to plus 1. So W1 is equals to 0.penta56 and W2 is equals to 0.8889. W3 is equals to W1. So let A is equals to 0, B is equals to 1, X is equals to B minus A by 2, T plus B plus A by 2. So putting the value of A and B, X is equals to 1 plus T by 2 and Dx is equals to Dt by 2. So Ft, substituting the value of X and Dx in the Fx. So Ft is equals to, for the limit 2y 1 plus whole square dt for the limit minus 1 to 1. So Ft is equals to 0.555556 f minus 0.7745 plus 0.7745 plus 0.888889 for F0. So the equation is 0.55556 into 0.493723 plus 0.2976 plus 0.888889 into 0.4. So now the equation is 2 dt by 4 plus 1t whole square, which is equals to 0.78527. So in this question, we have to write an algorithm for the middle rule for the 6 points. So first we have to read start, read end. H is equals to end minus start by 6. For I is equals to 0, I is equals to 6, read y I. So S is equals to 0.3, H 0 plus 5, y2 plus 6 by 3, y4 plus 5 by 5 and plus by 6, print S. Next, we have to write the algorithm for the Ranjit-Kutta fourth order method, which is define f x y comma y written expressions. Second, read starting ending splits. H is equals to ending starting y splits. So while starting is less than equals to ending, so k1 is equals to h star f x comma y, k2 is equals to h star f x plus h by 2y plus k1 by 2, k3 is equals to h into f x plus h by 2y plus k2 by 2, k4 is equals to h into f x plus h comma y plus k3, x is equals to x plus h. So starting starting plus h is equals to y is equals to k1 plus 2k2 plus 2k3 plus k4 by 6. So print xy. Next question is apply the predictor corrector method to solve dy by dx is equals to minus xy, where y0 is equals to 1 in steps of 0.1 up to y is 0.2. So yp n plus 2 is equals to yn plus 2hf x plus xn plus 1 comma yn plus 1, yc n plus 1 is equals to yn plus h by 2 f x n comma yn plus f x n plus 1 y n plus 1. By Hume's method, k1 is equals to f xi comma yi, k2 is equals to f xi plus h by 2 yi plus k1 h by 2, k is equals to k1 plus k2 by 2, yi plus 1 is equals to yi plus kh. Hence y 0.1 is equals to 0.9975. Y 0.2 is equals to y0 plus 2hf x 0.1 comma y 0.1 predicted. Y 0.2 is equals to 1 plus 2 into 0.1 x minus 0.1 into 0.9975. Y 0.2 is equals to 0.98005. Y 0.2 is equals to y 0.1 plus h by 2 f x 0.1 comma y 0.1 plus f x 0.2 plus y 0.2 predicted. So we can apply corrector formula again for a more accurate value by putting this corrected value as predicted value in the correct formula.